Hello, I'm Mr. McBrien. This is TIJ10 Arduino 5 Conditionals. Yesterday we talked about the serial monitor and how we can use it to communicate with the Arduino and let the Arduino communicate with us, especially when we're doing programming. Now today we're going to talk about starting to allow the Arduino to make decisions, enabling it to make choices. So how does a program make decisions? Well, if we want to understand how a program makes decisions, first, maybe we should think about the ways that we make decisions. We do them every day. So we examine data, and based on that data, we make decisions. As an example, if an alarm clock goes off, if our alarm goes off, what do? Well, we consider the situation, right? So we make a decision about what to do when our alarm goes off based on the situation we have at hand. We might consider, is it a school day? We might consider, how tired am I really? And do I have a test today? And that might affect the decisions that we make. We consider, in other words, the values of these variables when we make our decision about what to do when the alarm clock goes off. Well, as it turns out, the Arduino has the capacity to do the same kind of thing. Examine the values for given variables that are important to our system at hand and make decisions based on it. And it uses an if function to do this. So before we go and unpack the syntax of that if function, we can apply it to our situation of our alarm clock. So the alarm goes off. Our if function would look something like this. If school day is true, if it's a school day, we turn off the alarm and we get up. So what happens in this case, the stuff inside the curly brackets executes only if the statement inside the normal brackets is true. If it's a school day, turn off the alarm and get up. And along with these if functions, we often have what's called an else function. And the else code only executes if the stuff above isn't true. So if it's not a school day, we turn off the alarm and drool gently into the pillow. We can also use something called an elseif if there are more situations than just two. In this case, it's either a school day or it's not, right? Well, we can have our program examine things in more detail than just a yes or a no. We can have more situations, and we consider those with the thing called an elseif function. So let's consider if we want to, in our decision making around alarm clocks, have a little bit more versatility. We can do more different things depending on the situation. So we implement a slightly different function. So our alarm clock goes off, and if it's a weekend day, we turn off the alarm and do our standard weekend day function. Now, if it's not a weekend day, it's obviously a weekday. So we know it's a weekday, but we want to try to consider whether it's a special kind of weekday. So we have an else if function that says, is it a holiday? Now, if it's a holiday, we might want to get up even though it is a holiday. We might want to get up, but we don't want to go to school, right? So if it's a holiday, we turn off the alarm, jump out of bed, and check to see if anybody's got us any presents. And then we can still have the other situation, the unhappy other situation. It's not a weekend day. It's not a holiday. All right, turn off the alarm and get up. Okay, so This is the idea then of decision making inside the code. But sometimes a function needs to continue until a situation changes. Well, in fact, we already considered that situation. We're going to get to that in a second. But if we want to think in terms of robotics, maybe our robot wants to keep moving forward until a bump sensor is triggered. That's a Roomba function, right? So those automated vacuum cleaners, they keep moving forward until they hit a bump, until they hit a piece of furniture, and then they do something different. So that is a conditional loop. Or we might want to move a robot arm down until it blocks a laser beam. Keep moving, keep moving, keep moving. Oh, the condition of laser beam blocked has been met, and this loop stops working. There are lots and lots more examples of this kind of conditional loop. So if we want to implement a conditional loop, we usually use what's called a while function. We already saw this. We saw this yesterday. The loop keeps iterating while a condition is met. So the sketch keeps checking the condition, and when the condition is no longer true, it moves on from that loop. Another example, as long as the temperature is below 100 degrees, keep the heater going. If the temperature reaches 100 degrees, then it's going to stop throwing power to the heater and move on. So in this case, as long as the input from AO pin is less than 100, the power will keep going to the LED pin. That's a while loop. So where did we see this before? We saw this while we were waiting for the serial monitor. So as long as, in that case, it's a specialized thing where it's not running a heater, it's just saying wait. And we saw this here. Here's this command again. While there's nothing available in the serial monitor, wait. But as soon as there is something available in the serial monitor, then we assign whatever's in the serial monitor to the age in years. Now there's still more we have to look at in terms of decision-making systems. These are extremely important to computers and to various kinds of devices. So we have a lot of power here. So we have to also look at the concept of AND. Sometimes we want to meet two conditions before we make our decision. So we want to examine two separate things before we decide what to do. Now we can put conditions inside others. You could think of tricky ways to put one if function inside of another if function. And these are great exercises for you to do to get used to these things. But those types of nested functions are often kind of buggy. They're easy to put mistakes into. So instead, we've got an easier way. We use what's called an AND condition. If you have two of those things, the ampersands there, we can check two conditions at the same time. So let's go back to our alarm clock sounding. And should I get up? So the alarm clock sounds. If it's a school day and we're not sick, all right, alarm off, get up, go to school. All right, so we have to meet those two conditions. If it's a school day and we are sick, forget it, man, we're going back to bed. Okay, so that's an AND function. Now we can also do things called comparisons. We can compare one thing to another. And this applies to the situation where things aren't always just yes or no. Maybe we're just a little bit sick, for example. Or maybe the robot bumps something, but not hard enough to make it want to stop. So we need to be able to compare variables for certain situations, and we use these less than, equal to, greater than equal to functions to do comparisons. So we can still keep our alarm clock going for this example. So our alarm clock goes off, and we can say, if it is a school day, sure, yeah, it's a school day, but We also have to have our sick factor less than 40. If our sick factor is greater than 40, we're not going to satisfy our conditions. We're going to turn off the alarm, go back to bed. So if it's a school day, and if we're not more than a little bit sick, alarm off, get up, go to school. Now, in COVID days, of course, we might want to change our oogie factor to it has to be less than 5. And this gives you an illustration of the ways you can customize algorithms and make them make decisions based on the situation at hand. These days, if we've got the sniffles, we might decide to stay home, whereas in previous years, we might have said, I'm going to school. So this is a comparison thing. We've got an and a comparison thing here. So if either of these conditions are not met, if it's a weekend day, back to sleep. If our oogie factor is greater than 40, back to sleep. Okay, can we use conditions to schedule things? Absolutely. And the reason for this is that the Arduino has the capacity to measure time after it's powered up. So as soon as we connect power to the Arduino, it starts measuring the elapsed time in milliseconds. And we can access this anytime we want. We just create an unsigned long variable. I recommend elapsed time, but you can name it anything you want as long as it's descriptive. So we declare that as a global variable up at the top of the sketch. And then anytime we want to in the subsequent sketch, we can find out the elapsed time by simply accessing it with the milliseconds command. And this gives us tremendous power. If we divide elapsed time by 1,000, we can get the number of seconds since our Arduino started running. So here's an example sketch here, and really you can unpack all of this at a later point. I just want us to look at this value right here. Okay. So we retrieved the elapsed time in our loop, and then we immediately used that elapsed time inside an if statement. So if the elapsed time is greater than 10,000, in other words 10 seconds, and the elapsed time is less than 20,000, in other words less than 20 seconds, then in this case our pin 13 is going to go to high. Notice what happens in the else statement down below. Any other time other than between 10 and 20 seconds, our pin 13 is going to go to low. And so this loop can keep checking this whole thing. What's the net result of this sketch? This sketch is going to light the LED at a time of 10 seconds from when it's powered up. It's going to stay lit until 20 seconds, and then it's going to turn off and stay off forever and ever. So we can schedule then things to happen using a simple if statement. Okay, so there is a whole lot of decision-making power that we just got in 20 minutes of our time. Decisions in programs are made on the contents of variables. We use if statements to make commands execute only if conditions inside the brackets are met. If we have more complicated potential situations, we can use else and elseif to allow us to consider multiple situations. We can have while statements execute as long as conditions are met. We can have comparisons between given variables to decide whether to execute given commands. Maybe that's enough for today. For your homework, you're going to implement an age considerer that uses the serial monitor to find out the user's age and then decide what to say to them based on their age. Don't be too mean. Okay, the references, here are the references for what we discussed today. These should help you to execute on your assignment. Good luck, have fun, and have a great night.